This is Cortune, a project that connects biometric data such as heart rate to real-time audio feedback. In this video, I'll walk you through the tech stack, my Firebase setup, and the working mock demo of heart rate tracking. The tech stack is also better known as a list of technologies that will be used throughout the project. The main skeleton of the project will be React Native Expo. This is a single codebase for both iOS and Android, which compiles code to native code, which makes it easier to maintain throughout multiple platforms. This helps us by not having two code bases for both iOS and Android. For iOS, this is in Swift, and for Android, this is in Kotlin or in Java. For a performant cross-platform UI, I will be using Native Mind. It's still in CSS, but for mobile. Besides that, at the end of the project, I will be doing the UI and the UX using a UI kit like Tamagui. I'll probably also style most of the components myself. To gather the biometric data for the heart rate, I'll be using Google Fit and HealthKit. HealthKit and Google Fit aren't the only ways to access heart rate data. Some wearables support direct Bluetooth access using the heart rate service, and others like Fitbit or Garmin offer cloud APIs that let you fetch data from their servers with user permission. For my minimum viable product, I will be using Wear OS. This is because the wearable I'll be using is a Samsung Galaxy Watch, so I'll be using Samsung Health or Google Fit to get the heart rate live. Later in the project, I will be of course adding multiple different devices such as Fitbit, Garmin, Apple Watch, Xiaomi, and multiple other different devices which reads out the heart rate. I will be adding as much possible heart rate monitors in the end as I can. The reason for this is because more people will be able to use it. For testing, I will be mocking the heart rate, so I won't be developing with the heart rate sensor all the time near me. This will make my development much more easier and I won't rely on heart rate devices. For audio synthesis will be made with React Native Audio API. Essentially, this is the web audio API, but released for native code. I did a lot of research for the best fitting audio engine until I stumbled upon this package. It's only released 6 months ago, so I'm glad I'll be able to use this. For state management, I'll be using ZooStand, Async Storage, and Secure Store. This way I can use global state management, have local persistence for data and preferences, and can safely encrypt storage. For my backend, I'll be using Firebase. This is a very useful tool for authentication and for storing data per user, such as heart rate or preferences, in Firestore. Firebase is made by Google and well documented, so there are a lot of options within this backend as a service. When coming up with the name for the project, Cortune, I checked whether this name is already in use. This is for marketing purposes when I would like to advertise later on, so it's cheaper and I won't get confused with other companies. This is my centralized app config. Here I keep all my constants and settings clean and accessible. The App Store handles authentication state using ZooStand for global stage management. Here I made a protected routes component. This checks if a user is authenticated before rendering the content. Every sensitive page is wrapped in a protective route component. For example, the profile page, protected route profile, ensures only logged in users can access it. This login page uses Firebase authentication to verify credentials. On a successful login, the user object is stored in the global App Store. If the user, for example, doesn't exist, Firebase returns an error. Of course, before the login, you have to need the ability to make an account first. Here I'll make a new account with the name Siebe. Continue. I use the email test.test@gmail.com. Then I give up a password. I verify with a verification code if the email is in use or not. For now, this is hard-coded. And then I can pursue to create the account. Here in the Firebase authentication, you can see the account was successfully created. For now, to keep things simple, I mock the heart rate instead of using a wearable device for development. In this heart rate service file, I handle the logic for saving heart rate data to Firestore at intervals. Here in the mock heart rate.ts file, I created a simple function that mocks the heart rate. Instead of writing every 5 seconds to Firestore, we store locally in this file to minimize Firestore write costs. Here in Firestore, you can see that every 5 seconds in my collection heart rates, a new item gets added. I've also made a heart rate graph, which pulls from the global state to visualize heart rate in real time. Since it relies on the heart rate store, the component doesn't re-render unnecessarily. To finish things up, I made a simple navigation using Expo Router tabs. Each screen is a file in the app directory, making routes intuitive and scalable. The bottom tab navigation is implemented for quick access to main screens like home, profile, and sessions. The next step is generating sound based on biometric data in real time. Subscribe to my channel if you want to see it evolve. Thank you for watching.